Okay, so we've done a lot of kind of what I would call back end stuff all of this while, right? We have been doing Python, even the JavaScript we've done, the little JavaScript we've done has always been back end, right? We've been doing endpoints, we've used LangChain, right? LangChain to build back ends, we've used LangServe and all of that, Langsmith. We've even used Node.js with Express and so on to create backend endpoints. So we've basically been doing a lot of backend stuff. So last week, if you remember, we also talked a little bit about the principles of AI first UI and UX design, basically. And of course, we had a couple of designers to join that because I really wanted designers to hear what we have to say. And we saw some of the principles, of building good user interfaces, good user experiences, right? When it comes to AI first or AI enabled applications. So this week we have, and the next 2 weeks coming, which will be the last weeks of this training program, we will be looking at front end. So yes, for those who were doing Python and you were happy with all of that, um, everybody is going to learn a little bit of JavaScript. Like I have said, broadening yourself is very good, right? So don't restrict yourself to only one area. Nobody's saying that you should go specialized, or you should go specialize in, you know, JavaScript front end if you don't want to. Like if you're already doing, you already mastered the Python and so on. But it's good to know what is going on the other side. And I know there are a couple of people here who are also mobile, so it shouldn't be too difficult. So this week we are going to look at some basics of front-end AI, right? Not really looking at specific HTML, CSS code, which is not, for me, is not really a big deal, but looking at the principles of building, you know, on the front end. And we're going to use React and Next.js. So at the end of today and um, Friday's course, we are going to be able to integrate AI capabilities, into modern React and Next.js apps. We're going to look at how to do that and the principles. And we are going to just use very simple examples. Then we're going to look at things like streaming responses, some of the user experience improvements, right? Um, there's what we call streaming, and we'll talk about that. Then the other thing with these AI tools and AI, LLMs and APIs is managing tokens and rate limits is very, very important. Tokens are basically, just look at them like money because, yes, for all of this training stuff that we are doing, simple trials, simple testing, learning on your own, right? The free plan is okay that most of these AI providers give, right? Free plan, so it's okay. But when you start building real products, right, you have to go for paid plans. And paid plans, basically the token is a direct connection to your wallet, or your purse or your credit card or whatever that you have used to buy to pay for the plan. Once anybody has access to your token, they will use your token and they will run whatever, they want to run on it. So being able to safeguard and manage tokens, think of it the same way we manage secrets. Um, you know, front end is not a good place you want to store anything that is sensitive, and should be a secret, right? There's no part of the front end that you can store it that it's safe. You can't store it in local storage. You can't store it in cookies. You can't store it, in obfuscated, payloads, HTML payloads or whatever, or any other kind of payload for that matter, right? even though you have HTTPS that encrypts across the line or across the wire, right? When it arrives, there's still vulnerability. So the other thing is rate limit, right? Rate limit is the second aspect of how you manage your money, because let's say you are the one paying for LLM API calls, and then your users are paying you for that. Of course, they are paying you for the service that you provide in your app, right? But you still need to limit so that they don't overuse and finish, your own um, credits. The other thing we'll look at is how to implement a bit of voice interface, right? Um, because voice interfaces are like the next level. They've been there all this while and people have been doing it and everything, but it's gotten much simpler and simpler to do voice interface, right? The text to speech and the speech to text. We've already looked at that already, right? But this time we'll see how to incorporate it into apps using JavaScript. Then we'll end up with building a production grade chat UI. Um, we'll just start with it. So let's just jump into it. Okay. So the first thing is that typically, if you look at traditionally how we have been building apps, at least in the last 20 years or so, 20, 30 years, it's a client server, approach. You have a server that runs, and that server can hold your back end as well as a database, right? Servers are now in the cloud. And then you have a client, which is basically the browser. And on the browser, you have the front end. Now, the content, what really makes up front end and back end can differ, right? In some monolithic, what we used to call monolithic, approach, the whole code base is at the back end. It gets sent to the front end, and the entire code base is at the front end and runs at the front end. But there's still connectivity to the database at the back end. The database is still at the back end on the server, and the front end, a piece of the code base at the back end is sent to the front end as HTML, CSS, maybe JavaScript. It gets rendered, right? And you now have HTTP requests, to the back end. So that was the initial monolithic kind of thing. Even though the monolithic web-based thing was preceded by an actual client server where the client is on a desktop, code that you write, not with HTML, CSS, but with, Python, um, C++, and all of that, desktop apps basically that can connect, to the backend. And then over time, the client server thing kind of evolved into backend front end. And then even the backend front end evolved into having the backend as a separate entity and the front end using a separate framework with the frameworks that we currently use. For example, the React.js, which we are going to use for this, and the Next.js, which is a framework, what I call a meta framework on top of React, or Vue.js, and then Next, which is a meta framework on top of Vue, and so on. Then the Angulars and all the other ones, right? Those form front end, which have more functionality than the original CSS, HTML that we used to have before. And then they could still connect to the back end, right? So the front end became a separate thing. You could write an entire thing with front end, while the backend effectively became slimmer and slimmer, from being the entire thing to holding just endpoint code like what we have now with the likes of Fast API and Nest or Express.js that just hold endpoints instead of holding well, you still have the content of the front end on servers that gets sent or served to the browser, but it's in a separate code base, unlike before where you would have what we call monolithic, where everything is in one code base. So, but over time, we're now seeing situations where the backend has kind of become so slim, it's just a database, right? It just holds a database because you really cannot hold the entire database on the front end, even though you have distributed databases for things like blockchain and so on, Web3 and the rest. But yeah, so this is kind of the traditional web thing that we have been doing. We have front end, back end database. But now we have this new thing that the AI applications are bringing, right? First of all, you now have models. So models are a totally different thing, right? The large language models and other kinds of models. We've been talking a lot about large language models, but there are other kinds of models, right? The models now bring something new that never really existed, the reasoning layer to things, right? It's not like this didn't exist for your information. There were machine learning models before, but it's still the same thing. It's just that they were not very prevalent. So a lot of people were not infusing AI into their applications. It's only some specialist applications that will have machine learning layers that we're not using large language models, but other kinds of models. For example, um, the basic rule-based, algorithms, which we talked about some of them. Then what we call classical machine learning, using decision trees, random forest, support vector machines, um, you know, and other kinds of systems like that, even basic linear and logistic regression, right? But those could still be considered as a machine learning layer. In fact, there used to be rule-based kind of sentiment analysis. I remember using Watson. Um, there's IBM had a rule-based intelligent AI that we used to call IBM Watson, right? And it was very good with things like sentiment analysis, which is you take some um, text, you send it, it's trained on it, and it's able to tell you to extract sentiment out of that text and say, okay, this sounds happy, this sounds sad, this sounds angry, and all of that. Basically, basic classification algorithms, even in natural language processing um, area, right? Even in the image recognition, we had some specific kinds of handwriting recognition, some specific kind of computer vision, even before the large language models. So it's not like this is a new architecture. It's just that it was kind of specialized and in very niche areas. Okay. But what large language models have basically done is with large language models now, you can have the whole sentiment analysis, of course, you can do it with large language model, even though we are going to talk about some of the nuances around that. But yeah, you can do that. So the large language models and other models bring an added layer, the layer of intelligence, the layer of reasoning. So we now want to incorporate reasoning into everything, right? So we now find that the database is no longer the final layer, right? It's in this whole hierarchy. We now have the model as being the final layer. The model is the one that does the reasoning. And to do that reasoning, first of all, of course, it's trained on data, but it also reasons based on data that you send to it. I now find that the database is now vectorized. It's now a semantic database. So it's not just the standard database that has standard keyword search or standard text-based search, right? But it also has semantic search, right? So in fact, you find that most of the implementations of databases today, you can basically turn it into a vector database by implementing a vector index, a semantic index. And that's it, right? Even standard MySQL, PostgreSQL, SQLite, and all of those, right? If you just put a FICE, for example, a ChromaDB index next to it, and you link to it, it basically can become a vector database. But in this context, when we say vector database, we are talking about the likes of basically semantic database that has embeddings. You take the embeddings and then you form indexes from the embeddings, and then you can use semantic search to essentially pull the indexes that match, right? The embeddings that match. And since it is all indexed, right, it can be tied to a normal database. That's what Files actually allows you to do. And I think ChromaDB also allows you to do that. And the likes of Pinecone, which they've already done everything for you, you basically just connect to the API, get an API key, and then you have access to that. So databases effectively are becoming vectorized, vector databases, because semantic search is now very key. And when I say semantic search, what do I mean? If I want to search for something like, okay, um, what is maybe a movie title? So the movie title is something like um, I don't know what movie to use. Let's say Lord of the Rings, okay, Fellowship of the Ring, right? Semantic search allows you to pull movies that may not exactly have that same title, but have that same concept. Okay, that's semantic search. So it gives you a lot of additional flexibility than just the basic um, um, keyword search that you would have done. Because if you were doing keyword search, right, you'll be searching for Lord or Rings or Fellowship, and you may find other things that don't match that, right? Simply because they have those words in them. So keyword search is good for you to catch everything, but it's not able to filter to the things that really matter. Okay. So we can see that now the stack has expanded, right? We now have tools, right? Tools, of course, we know what tools are, the abilities that you give to LLMs, what they can do, what they may not be able to reason about, but if you tell them that they have these capabilities, then they'll be able to call upon those tools, right? And then at the end of the day, you have the gateway, the agent. The agent orchestrates all of these things, right? The agent orchestrates the tools, the vector databases, and the models, the LLMs. Of course, using the LLM as the reasoning layer to orchestrate all of this. Okay, so you now find that at the end of the day, the only thing that's not really changed is the front end. But like we discussed last week, the front end changes as well in terms of how we design things. But you now find that the front end has also kind of shifted, right? The front end right now is no more just for presentation, just for displaying what you fetch from the back end, right? Or for, it's still fetch even in the front end, back end, React and the fast API type of thing, right? It is still displaying what you fetch. The only difference in a React front end is that you are not fetching the HTML and CSS from the back end anymore, right? You are just fetching the data as JSON, right? And then you do the presentation and modeling of the presentation to display in the front end, right? But now, with this new paradigm, the front end is no more just to display and allow people to interact, right? And maybe do validation. The front end now participates in the entire AI stack, right? Because with a library like LangChain, which has a TypeScript, and even Mastra AI, which we are going to look at, a bunch of others, right? The front end can participate in constructing the prompt, in passing context around, in keeping the memory, right, in the front end, streaming the output that the LLM generates, right? Feedback from tool. The front end can participate in running the tool calls and returning the results back to the LLM, right? And maintaining the conversation state. So the front end now becomes a runtime layer for the AI. It's not just a dumb user interface that just displays things and allows people to interact and click, right? It can become smart and intelligent. The only thing the front end will not really be able to do is to host the model itself, because the model is heavy and requires a lot of compute. Even though there are there's the case we call edge devices or edge models that you can actually deploy at the front end. They are lightweight, but they're not because they are lightweight, they are small models. they can't do a lot. So they'll be used to just speed up and maybe distribute, right? Decentralize some of the things that the heavier models at the back end at the nodes would do. Okay. So this is a shift now. You find that if you're a front-end developer, you still need to know all of this, right? You still need to know all of this. So now that brings us to that same question, that dilemma of front end, back end split. Where do we split things, right? This particular question is, where should the AI call be? Okay. So right now we have two possible models that we are working with. So the first one is a very simple model that we were using when we were learning this thing. And if you are learning, you always start with that because it's very easy, right? The browser, okay, and then you send prompts to the backend. And the backend is not even your own backend you built, right? It's the backend from the AI service providers like OpenAI, Anthropic, Gemini, and so on. Okay. So what the browser is just doing is collect the user prompt, and then you do a fetch call to an API or use SDK to do something like client dot, conversation dot messages, dot, create conversation or something. You do an API call, but that's a very simple approach, right? And even though it has a few pros, yes, the architecture is simple. All you need to worry about is collect the prompt from the user. So you have a text area or a text box. Type in your prompt. Or in some cases, your prompt may not necessarily be a text area where the person types. It might be a button that the person clicks, and you have a pre-canned prompt that you have associated with that button. So for example, if the button says, okay, find for me other movies that are similar to this movie that I am watching, then when somebody clicks on that button, then what happens is that you already have a prompt that you have written and stored somewhere, and then you pull up that prompt and then you send it to the backend. But at the end of the day, right, your front end is basically just collecting prompts, right, and sending it to an AI provider. So you have low latency as well. It's one shot, it goes, it comes back. But there are some really big downsides with this simple approach. It is simple and is useful for learning, but this is not the kind of approach you will use for a production application, right? Some of the downsides, first of all, where are you going to store the API key? Because all of these API providers, AI API providers, you have to put in an API key. Of course, the API key is the control, the access control, like we said, that's where your money is, right? Even for a paid, sorry, even for a free tier, if somebody has your API key, they'll exhaust it and you'll be blacklisted or you will be rate limited. So you cannot make any more calls and you have to go pay to increase your limit. Okay. And of course, once you pay, then people can still wipe out whatever you paid for. So API key. So the question you ask yourself is, where can I store API key on the front end? Right? There's no way. There's nowhere. You cannot even obfuscate an API key. If you encrypt an API key and store it in the front end, you have to decrypt it, right? So any encryption, decryption, two-way thing, a hacker can break it. Somebody will visit your site and just basically, scan through, just, you know, filter through the source code, the raw HTML source code or raw JavaScript source code, and they'll find your keys there, right? We're going to talk about that a bit more. So the front end always exposes whatever data you have. If you put it in local storage, right? Um, of course, once the site is loaded, the local storage is easy to inspect, from the console of your browser. So the user will just open browser, open view source, or inspect, go to the console, go to the local this thing, and it will find if you put in cookies, it's still cookies are not encrypted, right? They're still in clear text. So there is no safe place for you to store secrets in the front end. That is why best practice now, if you are building any app that require secrets or API keys, right? Whatever needs that API key, do it at the back end so that you don't need to bring the API key to the front end, right? Because that will never get exposed. You never get loaded into the browser for people to see, right? And you don't have an endpoint. The only way people can get your API keys is if they hack the back end, right? And they have access, shell access to your backend, or you expose it to them through some endpoint, okay? Or they have access to your database, which is still shell access, or you kind of expose your database in some way. And that would be if you are storing the keys in the database. But if you're storing the keys in a .m file, for example, then they would need to have shell access, which is more difficult because they actually have to hack their way in, as opposed to the front end where they just they visit a page and it's loaded. So that's the first downside. The second downside of, using browser in this manner is that it's difficult for you to control the cost because people just access your backend, they access your the services you have paid for, basically the AI services. You cannot control the cost. You don't have any control because you are directly calling the AI provider directly, right? Maybe some of them may give you a way to manage costs or limit costs from the console, right? The admin console that they have provided. But it's still a limited amount of control. So you don't have much control. There's no observability, right? You cannot see what's going on. And security is weak. I've explained some of the things around security. So this is the main reason why you would not go with this option A, right? Rather, you would want to go with option B, which means that you have to build your own backend. So your own API endpoint or backend, basically, like what we have already done. Where whether you are using fast API and LangChain, Python, or you're using Node.js, Next.js, Express and Next.js, right? And you're using LangChain TypeScript, okay? At the end of the day, you have your API, right? Because you have your API, you can store your secrets in your .m files. I wouldn't recommend storing secrets in databases, right? Unless you have to. In some situations, you may have to store secrets in database if a good scenario is if you want to use your user's own secret, right? You don't want to pay your own money and let your users use your own API key to access. You tell the user, okay, go create your own API key and come and put it in here, right? Then when they do, of course, you're not storing. Remember, in this case, the API key is actually coming in from the front end, but you're not storing in the front end. It's not part of your code base. It's not part of your front end code base. It's data that comes in user input. You pass it across the wire. The backend will pick it up and can store it in a database, related to that user. But then you could also say, okay, I want to store it on the file system. It's a trade-off, right? But then again, database is still kind of a file system. It's just that it is more structured and more optimized. So, but in either case, it's an architectural decision you have to make. If I want to store in the file system, that means I'm allowing user write access of user supplied information. That is also dangerous because there could be vulnerabilities that come through a user sending you a command that you think it is data and you're trying to write it into the file system. If you don't sandbox your file system writing this thing, you could end up writing a user script, or payload, which they can later on activate, when they figure out a way to activate it. So those are some of the things to think about. But at the end of the day, those may be some scenarios where you will store API keys in the database instead of writing into the file system. But at the end of the day, you have more control. It's more secure, right? Then you can implement your own rate limiting so that your own rate limiting can be more severe, right? Or more conservative, right? Than what the API provider is giving to you. You can also write your own tools. You can write your own MCP server, right? Or just your own set of tools. So that gives your AI API more capabilities, especially capabilities that are not general. Maybe you have come up with some very, interesting capabilities I don't want to share. Or maybe your company has some things that are specific and proprietary to that company, and they're not open to the whole world. So you can write tools around those capabilities that only your AI is able to use. Then you can implement observability. You can link it to Langsmith or Langfuse, right? Or any other observability platform, and you can be monitoring what is going on. Then the last thing is you can cache those things. Even though the OpenAI, Anthropic, and Co would also provide some bit of caching, you can also do a bit of caching on the front end. But typically, caching is best done across, right? We'll talk about caching later on. But at the end of the day, right, you see that at the end of the day, the models are still at the end of the whole thing. Your agents orchestrate your models. Your API allows the browser to access your agents, right? And of course, I didn't add the other things that the agents will have access to, which is the tools and the vector stores, the vector storage, and so on. So this is what is recommended. You build your front end API to run on a browser, but you also, sorry, you build your front end application. By the way, for those who are mobile, when I say front end, I actually include mobile as well because mobile is a front end. Of course, it's not a back end, even though we call it mobile, but it's just a front end application that's optimized for mobile devices, right? Maybe you cannot run it on a desktop, okay, and it's not tied to a browser, it's not browser based, because you could also have a browser based mobile, what we call mobile responsive, right? So whenever I say front end, I am referring to mobile applications as well, the mobile front end. So the same thing, you can build a mobile application, right, that will still call out to, your API backend that you have built or the rest of your team has built. So this is typically um, what we would recommend. Now, in this situation, what does the front end do? What is its role? And so we are going to talk about that. So we'll start off by looking at typical Next.js. So Next.js is a framework that is built on top of React.js. React.js is a framework that is built on top of JavaScript, right? I call Next.js a meta framework because it's a framework built on top of a framework. Now, what does React do? React as a framework allows you to easily access the document object model, the DOM, on a browser without having to know too much about the document object model. So the document object model, the DOM, is the thing, is basically a mental model. Think of it that way, but it's also a software model of the capabilities or the things you can do in a browser or with a browser. Let's just simplify that way, right? So the DOM allows you, for example, to create documents. That's why it's even called a document object model, because technically the entire thing is called a document, right? That HTML, from HTML open tag to HTML close tag, is considered a document, a HTML document, and it has features. Essentially, HTML is a markup language, right? That's what the M in HTML means. That's what the ML in HTML means. It means markup language. The HT means hypertext, and hypertext basically means text that is hyper. You have, you know, hyped up. You have included additional capabilities to the text. So it's not just an ordinary text document. It's a text document that has hypertext. And HTTP is Hypertext Transfer Protocol. That's the protocol you use to transfer hypertext. And hypertext, what makes HTML hypertext is that you have the text content, but you also have the tags that are used to define how the text content should be displayed. So you have tags for anchor, tags for paragraph, tags for all kinds of things. Even the inputs that make up forms, you have tags for forms and tags for the input elements in the forms, including text area, date, drop down, select, and a whole lot of stuff, right? This is not really a class on HTML, but at the end of the day, HTML is just a way to represent complex information, right? Complex information instead of just simple text based. Because remember, all the information in a computer is represented with ones and zeros. Okay. And then these ones and zeros get translated into characters, which is A, B, C, D to Z, and a bunch of other characters, which forms what we call the ASCII code, right? So it all started with the ASCII code. The ASCII code only contained English and Latin characters and numbers and a few punctuations and other what we call white space characters. But yeah, that was because the whole computing thing started in the West, in America and Europe. But then again, the rest of the world got in on the whole deal. And the rest of the world figured out there are some languages that have more than 26 alphabets, like Chinese, Japanese, even the Russian languages, and so on. So they had to expand the character set from the 128 in ASCII to 256 in what we now call um, UTF-8, right? To Unicode. So Unicode is a full set that I can't even remember the number of characters you can represent with Unicode, but it's enough to cover all the different characters in all the different languages in the whole world. So yes, that's characters, right? So, but everything at the end of the day is still characters. Characters are not images. Characters are not, when you are typing a document, you make some things bigger in font size, you make some things bold, you make some things italicized and all of that. So single characters were not enough. We needed to find a way to kind of define how all of these additional attributes of, text can be, um, represented. So for example, how do I represent bold text? Different people came up with different things. Microsoft had their own system before, which is the .doc, and Apple had their own and Apple, but the HTML was just a way to unify it. So we now have tags. We have a B tag that means the thing should be bold. We have an I tag that means okay, anything in between this I tag, beginning, opening, and closing should be italicized and so on. So the whole thing is spread, and we had other things, including multimedia. So, okay, we can now represent text. We started talking about colors. We have color numbers and so on. Okay, so we can represent text and colors. What about images? Okay, so we now had an image tag to represent images. Oh, that's nice. But I want to also have videos on the web page. So we came up with, embed tags for videos and object tags and so on. So at the end of the day, right, HTML became what we are, what those of us who know HTML, what it is. But even when you don't know HTML, you know that all of the things in the web are built around that HTML. So um, we have HTML, right? But HTML was not enough. We needed it to be active. So then came along JavaScript. JavaScript as a language was able to bring life and activity to HTML. So it's not static. That's why it was called static, just dry, nothing. So with JavaScript, we had the language and then we had the frameworks. Okay. The frameworks are there just to help us to manipulate all of these things I just mentioned, which are all of the capabilities. So the DOM is just a representation, a way of how can we manipulate the contents that are on a web page, right? And that's what React does. React just allows us to manipulate the DOM much easier. And a lot of things I don't need to think about it, like what we call reactivity. That's where the name React comes from. Things can respond to other things, right? So that came up. And then Next.js now helps with React. So while React handles reactivity, the DOM manipulation, and then event systems, right? And a bunch of other helper, utilities, right? Next.js came up and said, oh, React is too complex. There's this thing we call router. How do I know which page to visit and all of that? I have to go and start building what we call a router and start configuring the router. So Next.js started off with, okay, let's do page-based routing. So let it just be the same thing like a folder in your computer. So and that's where this whole thing starts from. So this is kind of representation of a folder structure, and that's what Next.js brings. Next.js allows you to set up a folder structure, and then it converts that folder structure into a router, into a React router, basically builds a React router based on your folder structure. So you don't need to build routers. All you need to do is, if I want to go to this particular route, let me just create a folder structure and put files in there. And that's essentially what Next and Nox does the same thing for Vue.js. Vue.js does the same thing that React does. It basically provides an abstraction layer on top of the DOM, right? So how do we do how do you work with Next.js? I'm going to do a bit of hands-on on this shortly. But the main thing is that it just makes it easy. You create folders, you put TypeScript files, these files that end with .ts, you put it in the folder. So for example, in this one, we have an app folder, which is kind of the standard now for Next.js, what they call the app router. This anything inside this app will be added to the router, even though there are conditions around it. So this router becomes the route on the browser. So it just maps the folder structure to the route on the browser. So I can now go to API/chat/route on the browser, and it will take me to whatever is happening here, right? And do whatever, it will run this script file basically. And then if I have a TSX file, by the way, React has something we call JSX and TSX, which is just a way that allows us to mix in, HTML with JavaScript with CSS all in one place. Something that was always a taboo in those days, but now it is even the preferred approach. So with that, you can basically just create a TSX file. So you can ask the question, what's the difference between a .ts file and a .tsx? A .ts file typically will only contain JavaScript or TypeScript in this case. TS means TypeScript. So it's basically JavaScript that has some additional typing information. So it's a typed JavaScript. That's what TypeScript is. JavaScript doesn't have type. It's a loosely typed. In fact, it's an untyped language, right? But there are dangers in using untyped languages for production. This was one of the problems with JavaScript. So TypeScript came up to kind of improve JavaScript and add typing to it. So when you hear TypeScript, it's not really that it's a different language. It's essentially JavaScript, but it has typing information. Most other languages have typing information, including Dart for Flutter, including even Python. Even though Python is a loosely typed language, typing is kind of optional, but there's a base typing as well. It's kind of implicit typing. But JavaScript doesn't even have typing at all. So that's TypeScript. So the TSX is a TypeScript that has React that React can basically translate. You can mix in the HTML and CSS with it. So any file that you are able to mix HTML and CSS, you have to add the X at the end. So if it is a JavaScript file that you have mixed in HTML and CSS, you make it JSX. If it is TypeScript, you make it TSX. So that's the main difference. And typically, from a practical standpoint, TSX and JSX files are used just for the UI components. In other words, the user interface, the components that will be displayed, right? So there's now separation of concerns. You use the TSX and the JSX just to do the presentation, the components, okay? The user interface components. While you use the TS to store logic and code that doesn't have any UI aspects to it, but just kind of runs it does some algorithms, it calls endpoints, it handles data, what we call data transport, right? It moves data from one shape to another shape, it reshapes data, it changes types and all of that. So, and those other utility functions. Then, of course, you have the components, which is a folder, right, that you put in all your components. So this is kind of a very simple, there are a whole bunch of other files and folders that you would have maybe in practice. But this is like very basic and simple recommended way that you would, keep your folders organized when you're using Next.js. So this is the recommended structure. So the question now is, why is it better to use Next.js? Okay. Why does it work so well? Because Next.js allows us to have what we call server components, right? These are components that only run on the server. Even though recently, I think was it early this year or last year, there were a bunch of vulnerabilities that came in, through the server component of Next.js. They did fix a few of them, but a few of my servers actually got hacked, right? My VPS, one or two of them. Okay, it's only one of them because typically we deploy static sites. We do static compilation and deploy it. Like for me, because the easiest and the safest, right? We don't do that, live running node and then running, the node server and all of that because of some of these vulnerabilities. But that particular server, we did run a node instance and it was attacked. So anyway, yeah, Next.js has server components, right? That allows you to separate what you can still write components the same way you write React components, but they only live on the server. They don't get sent to the front end. They don't get sent to the client. They stay on the server. And when you visit that site, it's only the client side stuff that are sent. The server side components are kept there. So what that does is that you can keep your secrets in those server components and they can be safe. And then you can also execute AI calls safely. Even though, to be honest with you, I would use, right? I will not use a lot of server components, if any. I'll rather use only client components. And then I'll build my backend with Fast API. And I'll have a Fast API endpoint. Or build my backend with Nest.js, Node.js, and I have those endpoints. And I call to that, right? So there's still a bit of advantage and disadvantage to using server components. The advantage is the reactivity that comes with it because it basically will, when things change, your front end will immediately pick up those changes. Okay. But there is also that downside which we talked about. But yeah, that was just a vulnerability anyway, which anything can have vulnerability. So the other thing is that Next.js has route handlers, so because it has route handlers, it can work as your AI gateway. Then it has a built-in streaming support, right? So like I said, streaming is a situation where if the model is still thinking or the amount of output is a lot, you don't wait for it to generate everything before you send. You can begin to, you know, receive and display for the user the first few lines or first few as it is generating. That's why when you go to any of these, ChatGPT and so on, you can actually see it generating. That's streaming, right? It's still generating at the back end. That thing you are seeing is not front end thing. It's actually what's happening at the back end. But as it is generating each token, it is sending it across the wire to the front end, and you are receiving it and you're also displaying it sequentially that way for the user so that the user does not get switched off or bored or totally leave your site. This is one of the things we talk about user retention and user experience, usability. Um, Streaming is one of them. We'll talk about it shortly. So a lot of AI front ends use Next.js, mainly because again it's React. The community for React is very large. It's easy to get help. There's a lot of code that's been written, libraries, utilities, helper functions, all kinds of things. And in the AI space as well, you see that a lot of things have been written with React. So you don't need to write a lot of things from scratch. You can just go get, but of course, when you're going to get stuff, be careful, do a due diligence, check very well background check because recently I can even share with you a bunch of um, um, well these days in the area of skills, right? Cloud code. Somebody actually injected a malicious payload in a cloud code skill on cloud dot what do they call it? Cloud.hub or something, right? Um, so be careful. As far as this AI thing is concerned, right, things have not yet stabilized. That's the point I want to say. And standards have not yet been set. Regulatory compliance and all that have. So, and there are a lot of newcomers who don't have a lot of background in coding who are throwing things in. skills and all whatnot. So I just want to say, be careful what you go pull. It's better you write your own, or if you want to use, vet it very well before you use. So anyway, that's front end. So typically with that, you can now call a back end, right, that you have set up. If you use langserve like we should, your back end would langserve typically will give you endpoints for agents, and is very straight pass through, right? Langserve basically allows you create an agent, you stick that agent into a langserve um, create endpoint call, and it creates all the endpoints, including streaming endpoints. This invoke is just like saying agent.invoke, right, with LangChain. It also has agent/stream, so it kind of matches the API calls. Sorry, it matches the function calls. And so you can do these kinds of minimal client call where the first thing is you create an API call in your Next.js, right? So this is the Next.js where you create a route handler, right? And in this route handler, a route handler is still running in your Next.js, right? But it's a server-side call, okay? But this route handler um is calling a LangChain endpoint. And you can see it's localhost 8000. So this means that this is server side. It's on the server side of the Next.js in the same server as your LangChain API backend that you have written. So that's why it's using localhost. Okay. And then you specify all of this, right? You can do all of the API specific stuff here, transformations and everything here. So this is the Next.js route handler. Then this route handler is located in API/chat. That's where this route handler is located. So you can then call this from the client side, right? Which will be loaded to the browser. Okay. And you can say send message, you pass a message. So it's calling this. So what this endpoint you are calling is your Next.js route handler endpoint with the necessary payload. Then the Next.js route handler does a secondary API call to whatever API. So this kind of acts like an API gateway, right? Where you can, um, adapt it to any kind of API. The benefit of this approach is that if your backend API changes, let's say you're no more using LangServe, you use something else, or use a cloud API, you only need to make the change in this one place, right? But all your front ends do not need to you don't need to update it because this API chat will still remain the same. So it kind of helps with maintaining backward compatibility and being able to quickly make changes and updates. Okay, so the other thing is LangChain has this message format. So it's good to understand the format and structure whatever you're sending to the backend, right? Following this format. Okay. Structured messages will allow you to do tool calls like we have seen already, allows you to maintain the memory, the conversation history, and of course the multi-turn conversation. And it also helps with agent reasoning because if you just use a create agent to create an agent, then you just throw your tool calls in and then you have agent reasoning. So of course it's clear we are no more like in an age of just prompt, a single prompt. We are now in agentic age. So if you're writing an app, your app shouldn't just be, oh, let me collect a prompt from the user and send to the API provider, like we have said already. You should be able to build more features or capabilities around it. So yeah. Then streaming, I already talked about streaming. So the main thing with streaming is that if you don't have streaming, there will be about 5 to 15 seconds when the LLM is generating its response, that the user is just looking and watching a blank screen. Or if you are even very considerate, you can give him a spinning thing that just keeps spinning. People are that spinning thing doesn't work anymore, right? Because people are even tired of it. Okay. In fact, initially it used to be blank screen. Okay, let's wait. This page is loading. This page is taking time to load. Blank screen, white blank screen. Okay. Of course, you lose users immediately. Okay, so what do you do? The next thing is, okay, let's put a spinning thing there, right? So spinning wait icon. So people are waiting. Okay, at least now they know that the thing is still loading, right? But the new generation of users, that's not even enough for them. they don't even want to wait. Like, why am I waiting watching this thing spin? Okay. So the next thing we did was skeleton loaders that will be showing you the shape of the thing that's loading and all of that. But with AI, the fact that AI in the background, while you're waiting for it, is actually generating response. It's just that it hasn't generated everything yet. Do you have to wait for everything to finish generating before you begin to engage the user by bringing it to them? That's where streaming comes. So with streaming, as the backend is generating, the AI is generating its response, it is sending it token by token to you. So you can listen to a streaming endpoint. By the way, there's a difference between an invoke endpoint and a streaming endpoint. There's an endpoint you can actually do it, it will wait until it's all done before it's sent to you. But you can also listen or connect to a streaming endpoint where it keeps sending you as it is generating. So the beauty of a streaming approach is that they begin to see the thing coming and it can already begin to engage them, right? Of course, we are passed through all of that. So we see like that sometimes when you are chatting with ChatGPT and it's generating, you are reading it as it is generating, right? And at some point, you begin to focus on something it has generated. So you are no more following it because you're trying to understand what it's generating. And then it keeps generating. It kind of, overtakes you and keeps generating. And you already see the first few things. You might even find your answer in the first few lines, right? Or the first few paragraphs. So you don't even need the rest. So what streaming does is that it improves perceived speed by almost up to 5 times or more. Like you feel that the thing is 5 times faster. Not really that it's 5 times faster. It's still going to take the same length of time to finish streaming. But because you are seeing it earlier, right? You feel like, oh, okay, this thing is faster. Okay. So what's actually streaming are the tokens, right? The tokens, the LLMs generate tokens sequentially, and those tokens as it's generating is sending it back to you through the streaming endpoint. So as you are receiving, as your user interface is receiving this, it should be rendering it as well. Don't try to do anything smart or anything. Just render it so that the user sees it as it is coming. Okay. So the interesting thing is that LangServe allows us to stream, makes it very easy. If you use LangServe, there's already a stream endpoint, agent/stream, which you can post to that endpoint and you can then listen. And typically when you are listening to a streaming endpoint, right? If you are doing a string pass-through like with a Next.js route, okay, all you need to do is connect fetch to that streaming endpoint, right? And then um, the same thing as if you are doing content type application JSON. This is basically the same thing as what we did before with a non-streaming endpoint. This is a non-streaming endpoint. This is an invoke, right? This one will wait until it finishes before it gives you that response, even though some places might still stream, right? But a streaming endpoint is still the same thing. The only difference is that the response that you return from your own Next.js route is the content type is event stream, text/event stream, right? So that tells the browser that it is a streaming response that it is getting. Okay. So now the question is when you get a streaming response on the browser side of things, how do you consume that streaming response and immediately make it available to the user, right? That is where you use this simple approach, right? Typically, what you do is you will loop. You first of all run a fetch, okay? Fetch, the same fetch, right? The same fetch. Fetch is basically multi capable. It can do a lot of things. You still call that API endpoint. Fetch method is post. The body is still going to stringify it because what streaming, like I say, is doing is every token or every piece, it sends it as a separate payload. So it will send this as a separate payload, but this res, which is the result, the resource or handle, to the result, you can then create a reader from it. This is how you handle streaming. Unlike just saying res.json, which is what we would have done, in normal thing. You see this one, we just do a JSON, we do res.json. So we just get the full thing. Res.json, that's why normally when you do res.json, you have to await it. Okay. Here it is not awaited because you're already returning it from an async function. So you don't need to await. But if you were calling, when you are calling send message, you need to await it. And that's why JSON you have to await, because you have to wait for the full thing to be generated and then you receive it. It's a promise. So you have to await it. But for stream, right, you will see that um new response, right? You see that we are not really await. It's well, okay, we do the await to read the bits that has come in, okay? But when you are reading, you are going to get two things. Okay, so first of all, you get a reader, right? So you're not just getting JSON. If you're getting JSON, you have to wait and get the whole thing, right? But the reader allows you to get it piece by piece as it is coming, okay? Then you create a decoder. So this decoder is just a utility function that allows you to decode what comes from the reader into UTF-8 or something, because the stream doesn't come as a standard character array or a character stream. It comes as a binary stream, because streaming is supposed to serve not just character streams, but images and videos. It's the same approach you use for images and videos and a bunch of other things. So that is why you will use a reader to get it, and then you need a decoder to decode that binary stream into text. So you use a text decoder. So you're actually going to loop around it, right? And this loop is an unending loop. The only thing that stops the loop is when done is true. So done is only true when the reader has finished reading everything from the backend stream. So the reader, you await, the await here is just to await the small chunk that it is reading, not the entire thing, right? You await that small chunk that is reading, and then it's going to give you that back as a tuple made up of done, which means if it is true, that means it is finished. There's nothing more to read. The backend has finished sending. If it is false, that means you should still keep reading. Okay. Then value is the actual thing that is being read. So that's why you see that this done flag is what is used to break out of the loop. Okay. But while it is still reading, then you will now set the text. But remember, since we are using React in this case, right? React actually allows you to adjust some things to update. Basically, it allows you to update. So what is happening there is you are taking the previous value and you append the recently, decoded value or read value, which you decode through the decoder. So you can see that in this case, um, the next value, it keeps appending it to what was there before, okay, and uses that to update the text element, whatever it is that you're using. So this is typically, how you would do that. So some of the user experience tips, the usability tips around streaming is show the user some indication that you are still streaming, okay? And typically what you could do is that blinking cursor is one thing. There are different ways, other things you could do, but at least show something that the user can use to recognize that, okay, this thing is still streaming. It's not that it has gone stuck halfway, because if not, it may think it is stuck halfway. And the user will say, man, this thing has crashed, and try to refresh it. But if you have a blinking cursor, the user knows that, okay, it's still streaming. It's not done yet, okay? On some, you also even see a kind of a play button kind of thing where you would have normally um, clicked on the send button. It now turns into another button that is play. Okay, so those are all the small, small UI UX affordances that you just do to let people feel your app. Okay, and that's why I said design is very key. Imagine if you have a button, a send button, the person types in the prompt or whatever, clicks on send, but um, you did not change that button to indicate that it is still streaming. The person might click again. You understand? So these are some of the improvements. Then auto scroll is another thing, right? Don't let the thing that is streaming get locked at the bottom and there's no scroll bar, or even there's a scroll bar but you're not scrolling. Auto scroll is good because auto scroll allows the person to keep seeing the latest one. But the interesting with auto scroll is that if I now manually scroll down, it should not shift me back to the end. So auto scroll is if the person didn't scroll. But if the person scrolls, maybe I want to focus on one particular area. And this is like a standard practice, even in chat apps and so on. When new chat comes in, it pushes and it scrolls to that one. But if I am already scrolled down or up and I'm looking at something, it will be very disruptive and a bad experience for you to keep pushing, scrolling to the latest, and then I have to scroll back to where I want to read, and you scroll down again. I'm now fighting with the app. So auto scroll is good, but auto scroll needs to be smart to only scroll when the user has not manually scrolled. Then disable input while generating. That's what I just said. While it is generating, don't allow another prompt or input to be able to go in. So you can disable the button. Then allow cancel. This is very important. Like somebody can type something in and, oh, okay, it's taking 2 years, to generate. I can't wait this long, so I should be able to cancel. So it's all these small, small things, these micro interactions that will make your AI feel intelligent and alive, right? The interesting thing is you may think it is the final response that the AI comes with. Yes, that's an aspect of it. But an aspect of intelligence is also the user experience, how the app is actually behaving and is able to understand the user intent or desire. Okay. So there's another thing we call state management, right? Right? Asynchronous state management. And the main reason for this is that sometimes the AI response, we already know they will be slow, right? You're waiting for it to finish generating. So there is a tendency for things to take too long. So the other thing you can also do to kind of help and deal with that issue is things like caching and retries, right? Then background refresh and deduplication. Because it is slow, people may refresh, people may make the same request twice. You need to ensure that you deduplicate. Deduplication is remove stuff that are duplicates, okay? Then um, caching means if the same request is made multiple times, you don't need to call the backend again. Or if the request is even similar, we're going to talk about caching very soon. But the recommended pattern here is use a React query and use TanStack, right? TanStack React query. That's basically for some of you who have really done stuff, you are familiar with that. It's a utility um module that comes with React that basically handles the API connection for you. So you don't need to be worrying about API. Once you have set it up, right, and it's reactive as well. So you can make it clear the cache. It has a cache, built-in cache, and you can clear the cache whenever there are changes. But when there are no changes, right, it will load from the cached version so that your app basically improves, feels faster, and so on. Okay. So this is how TanStack looks like, and we are going to look at a few examples. So the golden rule is avoid manually juggling all this loading, error, retry, and stuff, because TanStack handles all of this, including the retries. Retries, if there is a network failure, you can give it retry instructions, how many times to retry, and so on. Refreshing in the background, when things go stale, and deduplication. So you don't have to write a lot of code yourself. You just use all of these libraries. Okay. Then I talked about token security. So this is one thing you never want to do. Like I said, there is no place in the front end where you can hide stuff. So don't put tokens. When we were doing a lot of learning, we did a lot of this, right? But we're learning. We're not building production apps. In production app, never do this. So what is wrong with this? That's the question you ask. What's wrong with this? The first thing is that this is running on the front end, okay? So even if you have put this in a .env, when it is compiled, it becomes accessible to the user, right? Whether you are compiling static HTML, static compilation, or you use Node.js to run dev or run in production, okay? Or npm run stats or whatever, right? This is going to, the key is actually going to be extracted from the .env file and compiled into the payload that goes to the front end. So people will see this key. And the worst thing is that any key that you prefix with next public, right? Next.js is going to pull it from your .env and it's going to load it into your this thing. In fact, whether you use that environment variable or not, right? It's only the ones that you don't have prefix, it leaves behind in the .env file. Maybe, I don't know, on the server side, right? Or server use. So don't put your keys in, don't prefix it with next public. Don't put it in the public space because Next.js is going to pull it and put it into a payload and your users will see your API keys. So the fastest way to kill an AI startup, is shipping API keys to the browser. Because what will happen is that all your users will load it. They'll use your API keys, they'll finish your money, right? They'll finish your money. Your limit will get exhausted. And well, I don't know. Imagine that happening so many times. Okay, of course, you have to go disable those API keys, but the whole way you coded it, you need to change. So the proper architecture is what we've already talked about. Your API keys should be in the backend, even if you are using server components, right? Next.js server components. Yes, those environment variables will be on that server side and they're never brought to the front end. So people never see it. But the extra things you can do is short-lived gateway tokens. Ensure that all your tokens, especially gateway tokens, are short-lived. You give it a time to live 20 days, 30 days, 2 weeks, you know. That's a bit of additional overhead for you because it means you have to keep creating new tokens and updating, but there are ways to do that. Then you have to have usage quotas. So even if, of course, you can only implement usage quotas if you have your own API. So you give each user a quota. If they call a particular, you can count it based on API calls. You can count it based on the number of characters that they sent to the LLM or the number of characters the LLM returned back to them. So all of that, you can just keep track and have quotas. And if anybody exceeds the quota, you lock out that person for a particular interval, maybe 2 hours, 3 hours, 2 minutes, or in some cases, an exponentially increasing timeout. So you could start with a 2 second timeout, but if they break it again, you change it to, to exponentially increase it 2 minutes, 10 minutes, and so on. So then, of course, ensure that requests are authenticated. Don't leave. There may be a few open, like, oh, anybody can just come and access your API or access your front end and do stuff. That's not really recommended. Let people create accounts and log in. So that way you limit to only those who really want to. You also lock out the bots and spiders and scrapers. Then do a per user tracking, right? So you treat your model access like a payment system because that's really what it is, right? If people are accessing your model, um, if you are giving a free tier, well, you're giving a free tier, so you limit. But if they are paying, of course, they have to pay. So you have rate limiting strategies that you can use as well. Even the legitimate users can overwhelm your system, so you have to do rate limiting because LLM calls are expensive compute operations. They cost you money, but they also cost in time, the time it takes to carry out that. So it's going to it's not only going to affect your pocket, but it's also going to slow down your service, your server, your endpoint, your backend, whatever. It's going to slow down your service. So you have to do rate limiting. And there are multiple places you can do rate limiting. Okay. You can do rate limiting at the what we call the Cloudflare Vessel Edge Fastly, right? These are cache servers, right? um, or CDNs, right? A CDN basically means a cache, a domain content delivery network, rather, a content delivery network. So that is basically um, networks that are close to your users, right? That catch the content and deliver it to them. So if the content is similar to what has been there before, they don't need to call your API backend directly. They just send that cache content. So that way it takes a lot of load away from your API backend because your API backend will only be hit if there is a new um, request or new content that needs to be generated. So this is one place that you can do rate limiting. It's very convenient when when you get an account in any of these CDNs, cache servers, content delivery networks. You can actually configure it and configure things like rate limiting there. Then the second place you can also apply rate limiting is in the API layer that you yourself have written, your endpoint, whether you're using LangChain or LangServe or whatever, right? You can implement rate limiting. And you can see here, this is like a good example of rate limiting. This is using JavaScript. There's upstash rate limiter, right? It's a service provider as well, right? And there are many others. This is not the only one. They have rate limit class that you can use. You pull up the configuration, and then it allows you to use Redis. Redis is a what we call a key value store, right? It's a high performance key value store that allows you to, it's not a regular database, right? That can store anything, but this one has few specific kinds of information it can store. That's why it's called a key value store. Things have to be in the form of key and value. You give it a key and you give it the value you want to store. And then you want to retrieve it, you use that same key and you give it the value stored. So it is used for storing metadata information that you want to retrieve very quickly. It's also very scalable. So you can use it for a lot of things for large scale applications. So Redis allows rate limits to basically um, initialize, and it is Redis that rate limit will use to store information on what people have been doing before, their access, basically you need to store history for you to do rate limiting, basically. And that's what Redis does for this. Then the limiter is the algorithm that determines how you do rate limiting. You're using a sliding window in this case with 10 counts, every 1 minute or something like that. So this is rate limiting. Rate limits protect latency. So it's not just about the cost, but also about loading your systems, right? Because if your models begin to queue and they cannot immediately give response because the infrastructure is loaded, then your user experience will collapse because people just don't like waiting. Okay. Then there's also another way you can rate limit using a pay user. You prevent power users because there may be some users that don't use that much and some users that are power users. So you have to be able to differentiate. Then the other thing I talked about caching. Caching is just a way to store information that is always repeated so that you don't need to regenerate them all the time, right? So a good example is that questions that are always the same or similar, and you know that your LLM will basically give the same kind of answer. So do you need to make an API call to the LLM to generate the same thing? Or do you just pull a cached response? Okay. So things like documentation questions, or how do I do this and how do I do that? You can cache. Assume you don't already have an FAQ, a FAQ, right? Which is even a faster and easier way. But then there are some questions that maybe if you don't have enough FAQ to cover it, or you didn't have time to build up a FAQ, right? So or FAQ. So what you could do is, yeah, LLM can do it for you, but you have to catch it to reduce the impact. Product explanations, internal knowledge-based queries. So these are typically kind of examples of things that are deterministic enough to catch. What I mean by deterministic is they're always kind of the same between one and the other, right? So you can catch them. And there are many different ways. So a route catch is one. Um, you look at a bunch of others here or looking at cache layers. But this is how you can implement it. You use a map. In this case, this is like a very simple implementation, right? You use a map. Why we use a map is a map allows you to store key values. So you can use the maybe take a hash of the message and use that as a key, right? And then you store or use the message itself, maybe, to store, right? So if the message already is in the map, then you just return that message. You return the response for that message. So you're using the message, that is the question itself, as a key. That's why I use a map. And then the response that the LLM generates is the actual value. So if that key, that question was already asked previously, you just pull the same response from the cache and send it back. But if it is not, then you can now call the API call to the agent with the message. But once the agent gives you an answer, you have to store that answer with the message so that the next request to that same question is you get it from the cache. So that's the benefit of cache. The cache is just a layer you put in front of your compute heavy, service, so that you only call it when there's, the cache. But sometimes the cache gets full. So there are also strategies with caching on when to kick or invalidate the elements of a cache so that it doesn't get full. Other new things can come in, right? Um, yeah, of course, like you can see here in a real production, you would probably use something like Redis or any other kind of caching mechanism. So when we talk about caching, there are many places you can do caching. You can do it at the browser. The browser has a built-in cache, but you can also implement it as JavaScript code. You can cache it at the API, like what this does using Redis. You can cache it at the API, or you can have a cache in the vector store, right? And some of these vector stores like Pinecone, ChromaDB actually have caches so that the same question, it doesn't need to re-embed that question again, especially if your embedding, you know, will cost because it's an API call, so it's going to cost you money. So if the question is similar, why do I need to do embed again, right? Or even if you put in an LLM context-based, response, why do I need to call that LLM again? So vector cache is also there. Then there is advanced caching strategy. So like this one we're having here, you put a message, right? But if there is a slight difference, maybe we change is to R or we change man to men, right? This kind of catching method will fail because the message is different, but the actual meaning of the question is still the same, right? So I will not go and pull it from the cache anymore because it changed from man to woman, or it changed from is to R, right? Or some few changes in not just semantics, right? Semantic changes are worth it, but changes in just the letters, the alphabet, the spellings, and things like that, even a typo. So that's where this kind of basic cache would fail because you go and pull, but it's the same, almost the same question. So you can have an advanced strategy where you have what we call semantic caching, right? So instead of using exact match like this, you do an embedding and you do a cosine similarity or any other kind of similarity index. So this can even improve your cost because now you are looking at similarity. And remember, everything when it comes to agent, it's all semantics. So that kind of, so I don't need to generate, for example, if the question is asked, what time, what time do I go to bed? Right? Okay, that's one question. The other question is, what is my bedtime? So those are two different questions, but the answer semantically is the same, right? But if you're using a basic cache, those two, the second one will be, it will cause another query because it's not exactly the same words. But if you use a semantic check, those two would give you the same vector or similar vector with a high similarity index. So with that high similarity index, I would not, I would say, okay, I'll still pull the answer that was generated for a similar question rather than making another API call, right? And the interesting thing is that LangChain has an easy integration with semantic cache, and we're going to look at that shortly. So, but I think at the end of the day, the key takeaway from this particular discussion is that you have to look at your cost. You cannot just be calling your LLM anyhow, right? Whether it is the one that you are paying for provided by an API provider or even the one that you're running locally on your own compute, right? It is still expensive either way. So only call LLMs when needed. In fact, one of the biggest jobs of an AI engineer or an AI developer will be how to optimize cost. And we're going to talk, in fact, there's a video I'm going to share after this class on the channel for you to watch, to think about what are the things to do, right? What are the ways? And you see that some of them even kind of cross over into machine learning, classical machine learning algorithms, and so on. So it is not free stuff anyway, we all know now. So I think it's something to pay attention to. So the other thing is handling retries and failures. This is basically a case of improving user experience, right? The models will always fail, right? And they oftentimes fail more than the typical API. In fact, there are times when I was grading, I am automating grading. I'm writing a lot of grading automation script. Sometimes when you write, you see the model just returns a blank, nothing, just blank. Maybe there is a two call, I don't know, but I never asked for two call. I never gave it two calls, right? So it just gives me blank content. So what I would do is run it again. So that happens, right? So you should expect timeouts. You should also expect outages from providers. There was a time when Anthropic, I mean, it was Claude. Claude went offline for a couple of hours. I couldn't access it, right? So always expect that. And what is your fallback? Then two calls can be malformed. And even if you give it a prompt and say, okay, respond in JSON only, make sure it's see, expect that your JSON might be malformed. So if you don't expect that JSON will have problem, then you end up with errors and all kinds of things. So these are all things to expect, and you work it into your plan. So the rule is never let the UI silently fail. That's another thing, right? When you're handling all of these things in the background, don't handle them silently. Send a message to the user. If possible, give as good a message as possible. One of the key things we talked about last week when we are talking about UI UX design for AI-enabled tools is transparency. Transparency is very critical. If you're not transparent, your users will lose trust in your app, and this is not something you want. So you should always be transparent, right? The best practice is tell the user something. The model is busy, I am retrying. But don't just give them an infinite spinning width icon or something. Transparency builds trust. This is very important. So this is also something, if you have retries, a retry pattern, right? Where we have what we call exponential backoff. So exponential backoff is you don't just keep retrying same interval. You might get rate limited or even blacklisted by the AI endpoint, right? Or backend. Even if it's your own and you wrote some code for that, right? So you have to back off, right? If you do a few retries, maybe after some time, you wait a bit longer before you try again. You don't just keep retrying with the same interval. That's what exponential backoff is. And what makes it exponential is that the time interval that you wait increases exponentially. It starts with small and over time it increases. Okay. Then conversation state. Yes, this is very important. If your AI doesn't have any prior context or information, it is not intelligent. It's no more AI. It's just AD, artificial dumbness. It's just being dumb, right? So what makes AI intelligent is that, yes, it can answer your questions, right? But as human beings, we are used to conversations that extend over time. In fact, the over time can even be over years. There is always context, right? You want to be able to come back to an agent and say, okay, that thing we discussed last year, hey, we want to continue, right? So how do you manage that? How do you implement that as a developer, right? So there are multiple ways, like we talked about. You can use a session ID, that's only browser. If you do only browser only conversation state, it's bad because once that browser clears, maybe it shuts down for some reason or the other, all that memory is lost. So if you are keeping browser sessions, always remember to back it up into your backend so that when we want to continue that conversation, you can use that same session ID, which you should have stored somewhere, and retrieve that history of the conversation. And when you retrieve that history, that is what you now use to kickstart or bootstrap the conversation history that you are having. So always ensure that you keep session IDs, right? And store the session ID. So like if you are loading from the backend, the conversation, the session ID will be there. And then from the session ID, you can now use a vector store or something, or you can even use the entire string conversation, right, as your history. And you load that up and you send it, and you know, the conversation now makes more sense. So you can see this in this case, a situation where agent is invoked, but you have this. So LangChain allows you to do this, or LangServe. Basically, this is the same API model. You pass it as a config into the LangServe endpoint, right? Config configurable. You pass the session ID, right? And it's able to retrieve the session, if you were storing it. So why this matters is that it enables things like personalization, conversation that, we reflect only that person. It also allows the long reasoning chains, right? Because sometimes you could even have reasoning that outlives the session you had with that model. Maybe you have closed the browser. You come back, it should be able to even pick up and continue reasoning from where it stopped. Okay. And then tool continuity. So if you had run 3 or 4 tool calls, you don't want to come back and rerun the same 3 or 4 tool calls. You maybe want to continue because the response from those 3 or 4 tool calls are still there in the conversation history. And then the LLM will reason from there, and it will not ask for those previous two calls. It will ask for new two calls that it needs to complete its reasoning. So memory is the second core element that makes AI to feel intelligent. Without memory, the AI, well, will not, even though it will answer questions intelligently, but inability to remember. Like I said, it will remind you of, you know, an old grandma that does not remember what you people discussed last week. Okay, so the other thing I would say you would really want to add to your application is speech synthesis, speech recognition. Okay. Um, this is an added thing, right? And it's becoming kind of a default interface. You should be able to implement it. Good news is that there are JavaScript, libraries built into the browser that allows you to do that. In fact, I'm actually going to show a few examples that I just implemented shortly before we pull everything together. So voice is rapidly becoming a default interface, right? So for Copilot, for accessibility is very important. In fact, accessibility is a key element of web development, right? But now AI now really brings accessibility to the next level, because before you would have to kind of re, uh, recraft descriptions for images, what we call the alt text for images. You will have to pre-craft, special kinds of responses for people who are are limited, basically. For example, people who are blind or deaf, right? So how do you work with that? But AI allows you to even generate such content on the fly, right? And then include speech interfaces as well, both speech recognition and speech synthesis, so that it is easier for more people to access and interact with your application. Then, of course, there's mobile AI, like I said, edge AI, AI that are deployed in mobile devices. It now is easier to do that, okay, then field workflows. So we are going to see how we can use this speech recognition API on a browser. And this is available on Chrome browsers and WebKit browsers. WebKit browsers are browsers that are based on Safari, basically. I Mac OS, iOS, and so on, Apple OS. So those are WebKit. And then the normal speech recognition is for everything else. Almost every other browser is based on Chrome these days. So it's actually very easy. You just create a new instance of it, right? And then you listen to this unresolved event, okay? Whatever you create a callback, assign it to this unresolved event. So once anything happens, once there's a voice input, right, the unresolved will be triggered. Then you can read from event of results 00.transcript. That is the transcript in text format. So this transcript is actually the result of the speech recognition in text format. You can then take this text format and do anything you like. You can send it to a large language model that will then do something with that and then give you a response that you can then generate speech synthesis. So we are actually going to try that shortly. So like I said, it works based on Chromium browsers. Um, there will always be a request for microphone permission because this is running on your browser, and browsers don't have that immediate access or default access to microphone. People have to give permission. So you probably have to tell people, even though there's always a pop-up that comes up for that. And then it provides a fallback to text, right? For people who may not be able to directly work with text. So voice reduces friction. So I would recommend trying that out and see how it works for you. Of course, yeah, after this recognition, the start is what will actually trigger it. So that's voice input. Then we also have speech synthesis, where you now have the text that the AI generates. Okay, you can now um, put it into speech. And again, you have this library, this API call or this function. Again, this is available in Chrome based browsers, right? New speech synthesis utterance, right? You pass in the text and it generates a new utterance object. Then you take this utterance object and you call speech synthesis.speak, right? And you pass in the utterance and it's going to do that. I'm going to show examples of this. This is not a complete example, but that's typically how it's done. So typically you would only use this speech synthesis um, when you really need to do things like summarize instructions and copilots. Avoid long monologues. So this is another thing to pay attention to. Remember that some of these GPTs can be very verbose, generate a lot of content. You don't want to pass all of that into a speech synthesis, stream. It's just going to be very boring. So you can summarize, or you can even instruct the LLM in your prompt that it should be very straight to the point and so on. So typically, because these things can fail, right? The speech synthesis can fail. It's always a good idea from a user experience standpoint. Stream the text first. The user can see it. Then when the response has completed streaming, then you start the speech. Okay. Otherwise, the audio can become chaotic because if you are sending a streaming response, right? The audio is not uh, optimized to be able to handle words that come in, in bits and pieces. So it may not be able to generate very good audio for you. So it's better you get the entire text, all the entire text complete before you pass it into the speech synthesis so that it does the best job. Because speech synthesis is not a unidirectional um, process or algorithm. It's actually back and forth, right? So if it goes back and forth and it goes back again and there's new information, it throws it off. Okay. Okay, so designing chat user experience, right? From the front end. These are just the key things, right? Um, the user experience is very important. Like I said, you can have a very intelligent app, but because the UX is not intelligent, people will still think it is dumb, right? So it is very important. The UX, like we said, things like you know, waypointers. If you are streaming, put a blinking icon, put change the state to show that, oh, I'm still streaming, and update quickly, use caching to speed up, and all of that. So these are some of the things that are really key, right? Streaming tokens, we've already talked about that. Markdown rendering, okay? So if you have Markdown, render the Markdown. So that's one thing because a lot of these um, AI will generate Markdown. So are you going to just print the Markdown with all of those Markdown markup? That's weird. But Markdown notations, right? No, don't do that. Render the Markdown so that it will come out as proper thing. And then the other thing is speech synthesis with Markdown. What do you think it will look like? So maybe you should render the Markdown. So you need to have a Markdown detector, right? To detect whether it's coming in as Markdown, whether it's coming in as JSON, whether it's coming in as XML or whatever, right? So that you know how to handle the text markup first, and then do that. Then if it is code, do code formatting. If possible, detect the programming language even, and use the markdown code formatting with the correct programming language so that it will show as code. We are all used to, we ask Claude or ChatGPT, generate code for this. You can see that when it comes to code, it will use a code formatting to show it, right? But if it is a normal chat, it will. So this all looks nice. If you're the one writing it and you didn't do that, it won't look intelligent, even though the answer is actually intelligent. Then you should have a copy button. That's standard. Now I think we're all used to copy button to click to copy, a regenerate button, um, thumbs up and thumbs down for you to get feedback and so on. Then citations. So if you're using a RAG that pulls data from this thing, there should be references and citations. So those are some of the basic must have, like basic, it should be there. Then what we call elite feature, like extra additional, that is you are a superstar kind of feature, is if you have tool activity, if you have a special way to display that, oh, this thing is doing a tool call, right? Reasoning summaries, you could even have summary, like as it is reasoning, you give it the reasoning lines and then the summary. Editable prompts. So a prompt that has already been sent, you have an edit button. We have that in ChatGPT as well, and a bunch of others. In fact, that's kind of standard now. If I cannot edit my prompt, it's like, man, these guys are behind, kind of thing. Then conversation branching. Conversation branching is basically a natural follow-up to editable prompt. If I edit the prompt and I generate, right, it will create another conversation. So should I override the previous one? No. So what some of them do is they have a page two. So they page two, they now put that in page two and they show you, okay, two of two and so on. So these are like stuff that we already are seeing in some of these AI user interfaces, right? So for me, I would even say, what more can we add to improve this? So at the end of the day, right, this is like what should be recommended production architecture, right? You have React Next.js or any other front end you want to use, including even a mobile app. You do your API route, then you use langserve to serve, right? If you are using a Python backend, if you are using langserve, of course, runs with fast API. If you're using a Next.js, Node.js backend, then you may not be able to use langserve, but there are other equivalents that you can use, right? Then you build your agent, right, with LangChain or any other thing, and then you have your tool calls, you have your vector database for your RAG to pull semantic data to enrich and enhance, the context that you send to your model for this thing. And so this is typically like what you say is the best. So this is a secure architecture, it's observable. You can plug in Langsmith here or Langfuse. I didn't talk about Langfuse, by the way. So Langsmith is we might actually have opportunity to touch Langfuse a little bit. Langsmith gives you observability, but it is a SaaS platform that the LangChain provide for us. But it's not open source, so you can't install it on your own server. But Langfuse allows you to achieve or get the same kind of features, but you can install Langfuse on your own server. It is open source. So observability is very key, evaluation is very key, scalability is very key, enable provider agnostic. This is very important. Your back-end model provider should be able to switch on the fly, even detect when the provider is down and switch to another one, right? So those are all some of the things that we look at. So that's it in terms of how we build front-end AI. Um, we are going to do a hands-on lab when we come back because we've kind of run out of time, right? We are going to do, but I will share a kind of bunch of, um, you know, directions later on today that you can follow, right, to build this. And like I said, I'm going to also share a link to help you understand what really is your role if you now want to go deeper into this thing, right? I now know how to build AI front end, AI backend, agentic capabilities. There's still more to agentic, by the way. That's in the agentic class, which maybe in the next cohort, some of you I would recommend some of you based on with this armed with this background you have, you will be a much better, when you're writing agents, you'll be far better able to understand what's going on. But as it is now, you can already write agents, right? Agents are essentially, um, you orchestrate, you write code that orchestrates um, LLMs around tool calls and RAG, and then you can add anything else. But just starting with that already gives you a lot of capabilities. So now when we come back, we're going to build a production style AI chat app. We're going to have a RAG based, a tool enhanced RAG agent, basically an agent that has tools and has a RAG as one of the tools. So we're going to build a RAG. We'll now toolify that RAG by essentially attaching it to a tool function. And then we may have a bunch of other tools. And then you build an agent um, with that, okay? Then you build an endpoint, right? We'll push it out on LangServe, okay? Maybe add Langsmith for observability. And then we have a backend. Then we'll now take that backend and then we're going to build a simple chat user interface using React based on all these principles, okay? Including things like caching and some of these things, LangChain for on the front end also provides it. So it's interesting that we'll be using LangChain on the back end, we'll also be using LangChain on the front end, right? But we won't use a lot of LangChain. This is just to give us an idea. Then next week when we come, we'll start with Mastra, and then we'll replace the entire front end. Instead of using LangChain, we'll use Mastra AI. So, but we're going to build a simple chat application. I know a lot of you started off building a chat application when we started this course. But the simple chat application you did was the simple one, right? It was this one, right? It was this one that we said option A. That's what you built, where you just did a browser and then you called out to an endpoint. But now we are going to build option B, where you're now going to build a very powerful agentic, backend of your own. And then you still put your chat interface to it. So I'm going to share some tips on it so you can also try. And then we are going to jump into that when we come in. So that's it from me for today. Um, I'm going to close early, even though it feels like we are closing early because we always tend to do a lot of things. But I'm going to close early today. And if there are any questions, yes, you can ask them now. We'll do the hands-on on Friday. Are there any questions?